Alright, so it's been quite a while since I've done a straight up how-to video, so I'm going to interrupt the projects for a moment and do one for y'all. This one's going to be how to diagnose a no spark situation. Probably one of the more maddening things about motorcycles is electronic work. A lot of people have a hard time with it. I'm one of those people. It's just one of those parts of motorcycle mechanics that that's just hard to visualize. You know, you can sort of figure out how gas flows from the tank to the carburetors into the engine. You know, that's fairly easy. But the way that relays and coils and, you know, CDI boxes and all that work, sometimes it's just hard to visualize. So I'm going to tell you guys a couple of tricks that I use to diagnose why a bike isn't sparking. These won't be entirely universal amongst all motorcycles, but if you have an old Japanese bike, it should help you out. First off, you need to determine whether or not it is sparking. Don't just assume, oh, the bike doesn't run and therefore it's not sparking. You need to test the spark. That should be your very first thing. So I'm going to show you how to do that. This here is a spark tester. I bought it on eBay for like $3. Super easy to use. Basically, you plug this onto your spark plug and shove this into your spark plug wire, and then you crank over the engine and the little light will light up if you are indeed sparking. So yeah, we're sparking, the engine's running. That's a positive sign. Another way to do that is the old-fashioned way. If you don't have one of these, you can use a screwdriver. So you just put a screwdriver up the spark plug hole and then bring it close to the head of the motor. If you see the spark fly, then you know that you're sparking and you're good. So you can use a piece of the frame, piece of the exhaust, or whatever. It's just any good ground. Remember that these two tests, all that they do is they test that there is spark getting to the spark plug boot. It's not testing the spark plugs itself. So if you have dirty plugs, if they're wet or fouled for some reason, you could be sparking absolutely just fine all the way to here, but not inside the engine. So in order to test your spark plugs, this is how you do that. We're going to take the spark plug out. I just grabbed a different spark plug so I didn't have to pull this one out. But you would basically pull this one out, put it in its boot, and lay it against the head of the motor, just like we did with the screwdriver. And then you look right down in there as you turn over the motor. So those are all positive signs. They all mean that this bike is sparking appropriately. Remember, you don't have to have the engine actually running. All it needs to do is turn over with the starter motor. So, I mean, if you've got a kickstart bike, you can get someone to watch while you kick it. But that's how you test. These are three ways that you can test your spark. If you find that you are not sparking, you can't get it to spark, this is what you do. Remember also that the quality of the spark is important. So what I was seeing were nice, big, fat blue sparks that were coming through here. If your spark is yellow or orange or intermittent, you know, it comes and goes, consider that a negative sign. Consider that just as, you know, as well as if you weren't sparking at all, because something is malfunctioning. And usually a spark like that is not sufficient to reliably combust your gasoline. So if you find any of these problems, this is what you're going to do. First thing we're going to do is get ourselves a multimeter. It is going to be very, very difficult to reliably find the source of your spark without a multimeter. These things are for sale at $5 at Harbor Freight. You can go to any auto parts store, buy them for under $10. They're super easy to use and cheap, and there's really no reason for anyone not to have one. So, got my multimeter, and we're going to test the battery. Now, just because your battery has enough light or has enough power to turn on your lights or to turn over the starter motor does not mean it has enough power to make the spark. So what we're going to do is set it to volts. I set mine under 20, and we're just going to test the battery. Red to positive, black to negative. just like that. I'm reading 13.1 volts. That's really good. You definitely want something over 12.6. Once you get down to the lower ranges of 12, your bike's going to have a harder time starting. I've gone into this in other videos. I've got a good battery video. I've got a video of what is required of a battery when it starts a bike. You know, a whole lot of things have to happen, and the battery has to power them all before your bike can even start up. So you need a really good battery. Going concurrent with this are all your battery connections and leads and stuff like that. Here we have a connection which runs through a fuse, and then it goes to the starter solenoid, and this one is your ground. You're going to want to take this apart and scrub it up with a little file or a piece of sandpaper or something like that, and really clean it up. Because even though you might have a good battery that's charging well and everything, if you have corrosion in here that's robbing amperage and it requires extra heat to push the energy through, then that might rob energy for your bike, and that might be why you're not sparking. So just go through your connections, go through here, find your ground on the other end of this wire here. Just, go through it all, clean it up, and do the best that you can. Now, starting in the 1980s, Japanese manufacturers went nuts with safety switches, and they started putting all kinds of safety switches on these motorcycles so that people wouldn't accidentally start the bikes, with the kickstand down or in gear, and rock it off like that. It's all a good idea, and I'm sure it saved a couple of broken shin bones, but fast forward 30 years, now guys like you and I are struggling with these switches, which have been sitting on this bike for 30 years, and now they're all corroded and they don't work anymore. So some common places to find these safety switches are up here in the clutch handle. Sometimes you need to have your clutch pulled in order to start the bike. Sometimes, especially like on bikes like this Yamaha Riva scooter, you need to have the brake pulled in order to start it, or else the starter button just will not work at all. Sometimes you have to have your bike in neutral, so there's a safety switch down at the down in the transmission that detects when you're in neutral, and if you're not in neutral, then your bike won't start. A very common one to fail is the kickstand safety switch, and I have a video on this one as well. Kickstand safety switch is all the way down there, and if it fails, if it's stuck in the the open or the closed position or whatever, then your bike won't start as well. There are two different ways that these switches can work. The first one is either it creates continuity or it breaks it. If it creates continuity, let's say when your kickstand is down, that means it grounds out, your coils or your starter circuit or however it works. It'll ground it out, and therefore won't allow you to turn the bike over or to start the bike. Or if it breaks the continuity, then it breaks that ground and allows the bike to start. So they can work in opposite ways, but basically so long as it works as a switch, it's probably doing its job. So this is how to test it as it works as a switch. Alright, so this is your basic kickstand switch. Just looks like this, and it's got a pigtail of two wires coming out of it. You're going to use your multimeter again, and you're going to go ahead and turn it to ohms. So I just put on 2,000 ohms. That seems good enough to me. You're going to stick one lead in each of the pigtails, as you can see I've done. And then just watch your multimeter change as you push this thing in and out. You can see it's out. It's totally, out and extended right here. And so we have almost no resistance. It means that, electricity is flowing through it. So when I push it in, you can see it turns to 1. That means there is resistance. Out, and it goes back down again, in, just like that. So this is a good switch. If it didn't switch back and forth, like you can see my multimeter doing, that means the switch would be bad. So if that's the case, you have a couple of options on how to repair it. You can go on eBay or whatever, or go online, try and find an extra one of these somewhere. Make sure that it works before you buy it, install it, and there you go. Or if you don't want to do that, what a lot of guys do is they just bypass them. If you know your bike and you know that you're not going to start out in gear, it's really not that big of a deal. And so to bypass it, all that is involved with that is to just cut these wires here and splice them together, or insulate them apart, depending on how this thing works, as I previously mentioned. So if you have a switch up in your clutch or your brake, it's going to work in the same way. Additionally, depending on your bike, your kill switch might be causing the problem. Some bikes, if the kill switch is on, you can't even start the starter motor. Some bikes, you can start the starter motor, but the engine won't fire. So you just check your kill switch. You can unplug it. Take this this assembly off. Okay, unplug the wire here. It's got two wires, just like the just like the kickstand switch does, and you test them in exactly the same way. You put your multimeter leads in there and just switch it. Okay, interrupted, continued, interrupted, continued. If you see that your multimeter is changing back and forth, just like I just showed, you're good to go. These are what is known as relays. They're basically switches, or basically like a starter solenoid switch. When you put electricity across two leads, it flips a little switch, flips a little breaker, and it allows electricity to flow across two other leads. Neat little things. Sometimes they do fail. On bikes with safety switches, you're going to find that a lot of times you'll have stuff like this. Basically, the safety switch will switch the relay, which will ground out or interrupt the connection to the starter circuit or the ignition circuit or whatever, and that's how that works. Sometimes these things do fail. They are worth checking out, seeing if they if they work. What I will do usually to test them is I'll just take jumper leads from a battery and start touching them. Start touching different combinations. And if I hear it switch over, if I feel it click, then generally it's going to be okay. Sometimes not. Sometimes they click and they still aren't making a connection, and all you got to do is replace them. So I don't really have very good access to information like, oh yeah, you got to touch number 1 and number 2, and then if you have continuity against 2 and 3, then then it's a good switch. I don't have good access to this type of information, so. If I'm at all concerned, I might try and find some guy on a forum who absolutely knows. If not, then, you can find these pretty cheaply. Just make sure that you get the right one. And there's the number right there, because even though these look the same, they do totally different things. See, this one's 4H701. This one's 3H500. And so they might even accept the same plug, but they won't work the same. Alright, next step is going to be to locate your fuse box. Usually in these old bikes you're going to have an old fuse box, something like this. Sometimes they'll be upgraded to the blade style fuses, and rarely you'll have inline fuses, which are basically, let's see if I have one. I don't have one on this bike, but it's basically just a fuse that someone put in line with the wire. So keep an eye out for those. Most bikes will have a separate fuse just for the ignition. That's this one right here, this 10 amp fuse. And you're just going to take a look at them, make sure none of them are busted. And then you're going to pull them all out and scrub them up with some sandpaper and get all that corrosion and junk out of there. After that, you're going to take your multimeter and put them on. What I do is I put them on the clips, not on the fuses themselves, but on the clips, and check for continuity. This makes sure that you have current that flows from all the way right here up into the clip, into the fuse, across the fuse, back into this clip, and then all the way down right here. So it checks the entire thing, not just the fuse. So you check them all, just to be sure, but definitely check the ignition one and make sure that A, the fuse is good, and B, there isn't a little bit of corrosion in there that's causing your problem. So once you've done that, it's time to check the ignition coils. The ignition coils are connected to your spark plug wires. A 4-cylinder bike will usually have 2 of them. A 2-cylinder bike will have 1 or 2, and they're going to be up underneath your tank. So you're going to rip this tank off and try and find these ignition coils. I have a pair set over here. This is what they look like. So there's 2 things that we need to check on the ignition coils. The first one is the primary, and the second is the secondary. This is how you're going to check your primary. You basically put your multimeter back on ohms, and then you stick them up the pigtail of your ignition coil here. Just go ahead and stick it like this, and then see what you get. You can see I'm reading 12, 13, somewhere in there. Depending on your ignition coils, and depending on your bike, you should be somewhere in the range of like 2 to 5, something like there. Here I've got my repair manual here. It says 2.5 plus or minus 10%. So the most I should get is like 3, 2.753. I'm getting 13, so these are definitely bad coils. Now to check the secondary coil, there's 2 ways to do it depending on your bike. First way is to leave one of your plugs in your pigtail here and connect the other one to one of the spark plugs, just like this. And you can connect it to either one, it doesn't matter. And then you check your resistance. You should be up in somewhere of like 11,000, 15,000, somewhere like there. So you're going to want to change it over to 20,000 maximum, from 200 over to 20,000. So that's one way. And I know that like Hondas are like that and yada yada. Anyway, for this old Yamaha, it does a little bit different. You got to plug them both into the spark plug wires. You got to plug them both in like that. So I'm going to check it just like this. So I got them both in like that. You hold them in. Nothing. So we already knew this was a bad coil, but this is definitely a bad coil. Now, underneath this little engine side cover here is what are called the pickup coils. This is the next thing that we're going to test. You're going to go ahead, expose these, pull them out, and we're going to test them. You don't have to take them out if you don't want to. Just follow the wires all the way back up, and they should plug into your CDI box. So you're going to go ahead and pull them out. This is what they look like. Just like this. And this is what the plug looks like on this Yamaha. And so now I'm going to set up the test on how to check the resistance on the pickup coils. Alright, so this is how you do this. You've got 2 sets of pickup coils, one here, one here. Go ahead and look right in here and look at what color the wires are. We've got a black one and we have an orange one. So then we follow it all the way up here to the plug, and you can see we've got a black and an orange right here. And so we're going to test the resistance between these two, and on this old Yamaha it should be about 700, give or take 10%. So like, 630 to 770, something in there. So I'm going to plug it into the orange, one in the orange and one in the black. And you can see it's not exactly consistent. I mean, it's oscillating around a little bit. Wait for it to settle. And I've got about 670. So that one checks out. Now we're going to do the other one. This one is black and gray. So we're just going to flip it over. And this one's reading about in that same range as well. Wait for it to stop. This one might be a little bit high. There we go. This one's okay. So this checks out. So if all that checks out, all your coils, all your connections, your fuses, your battery, everything, all that is fine. You've got the correct plugs plugged into here. All of that is absolutely hunky-dory, then your CDI is bad. And unfortunately, there really isn't a good way of testing your CDI except for plugging it into a known running bike. I've struggled with this on eBay. Guys are trying to sell me a CDI and they say, oh yeah, check continuity and continuity is great, so it's a good CDI. No, I mean, you can put your multimeter leads on the little plugs that come in here, and sometimes they have continuity, sometimes they don't. That doesn't mean it's a good CDI. There's a little computer in here, and it flips over and it does its thing. But what's important to remember is that that for the vast majority of these bikes, this is the only way of testing them. I mean, there's just no way around it. Sometimes you'll get lucky, you know. Sometimes you'll see in your repair manual, oh, you know, check here and here and here, and if you get this much resistance, then your CDI is good. Usually it's not. I can prove it to you if you don't believe me. This is a little flow chart similar to the ones I make. It's in my Maxim XJ650 repair manual, and it says exactly the type of things that I've been telling you. Check your connections here, check your battery, fuses, coils, and if all of this is okay, so you go, okay, check this, okay, then the TCI, and they call it, or Yamahas are called TCIs, TCI CDI, is faulty, replace unit. And you can see that there's no way to test it. There's no specifications on how to test it, so I'm not making this shit up. Well, that's basically the thick and the thin of it. I wish you all the best in your electrical diagnoses. As far as the CDI or TCI box goes, you know, I wish I had some better news for you, but that's the only way to test it. Something that I have done in the past, I've gotten on a forum and contacted a guy who had a same bike, and I was like, hey man, can I mail you my CDI box and you plug it into your bike and see if it runs? Usually people on forums are really trustworthy. They take really good care of your parts and everything, you know. Because it's a public forum and you're accountable for your actions if you want to stay in good standing with the forum. So that means a lot to some people. I know it means a lot to me. So when people send me their CDI boxes to test on a bike, I always take really good care of them. So you know, that's it. You know, good luck and everything. If you guys have any questions about model specific bikes, you know, you want to see if I can help you out with getting that algorithm down, I'll be happy to help you. Just go ahead and send me a message and I'll do my best. Alright, well, take it easy.